Guys, today we want to learn how to find the eigenvalues and the eigenvectors and how to diagonalize. So we're being told to find the eigenvalues and the eigenvectors and hence diagonalize. So to find the eigenvalues, let's start our solution. We want to find the eigenvalues. Now we should know that the solution to the determinant of A minus lambda times the identity matrix is equal to 0 will give us the eigenvalues. So when we get the determinant of A minus lambda times the identity matrix, which is always equal to 0, then the solution will give us our eigenvalues. So our A is 3, 2, we have 4 minus 4 minus lambda times the identity matrix, which is 1, 0, 0, 1. So we find that this one will be equal to 3, 2, 4 minus 4 minus my lambda times 1 is lambda, lambda times 0 is 0, lambda times 0 is 0, then lambda times 1 is lambda. We realize that when we take A, this is our A, and this one is our lambda times the identity matrix. So 3 minus lambda is 3 minus lambda. Then we have 4 minus 0, which is 4. We have 2 minus 0, which is 2. And we have minus 4 minus lambda, which is minus 4 minus lambda. Now we need to find the determinant and equate it to 0. And the solution that we will find, that is lambda 1 and lambda 2, will be our eigenvalues. Now to find the determinant, we want to find the determinant. Determinant is equal to 3 minus lambda times negative 4 minus lambda minus 2 times 4, which is 8. And this should be equal to 0. Now let us expand. Let us expand this. We have 3 into negative 4 minus lambda. Then we have minus lambda into minus 4 minus lambda. Then we have minus 8 should be equal to 0. Now expanding this, we have negative 3 times 3 times negative 4 is negative 12. Then we have 3 times minus lambda is minus 3 lambda. Then we have negative 1 times negative 4, which is plus 4 lambda. Then we have negative lambda times negative lambda, which is plus lambda squared. Then we have minus 8 is equal to 0. Collecting like terms, let's start with the lambda squared. We have got lambda squared minus 3 lambda plus lambda is plus lambda. Then we have minus 12 minus 8, which is minus 20, is equal to 0. Now we have got a quadratic equation which will give us lambda 1 and lambda 2. Now to solve this, we look for two numbers. When we add, we find 1. Then when we multiply, we find negative 20. We find that the two numbers are negative 4 and 5. So lambda squared minus 4 lambda plus 5 lambda minus 20 will give us 0. Therefore, we factorize. We have lambda into, we have there lambda minus 4. Here we factorize 5. We have plus 5 into lambda, here is minus 4, is equal to 0. Now we pick lambda plus 5. Then we pick 1, lambda minus 4 is equal to 0. We realize that lambda plus 5 is equal to 0. And here we have lambda minus 4 is equal to 0. Therefore, here lambda is equal to negative 4. Lambda is equal to negative 5. Here lambda is equal to 4. Therefore, our lambda 1 is negative 5. Our lambda 2 is 4. So these are our eigenvalues. Now from our eigenvalues, we can find the eigenvector. Eigen 1 is negative 5. Eigenvalue of 2 is 4. Now to find the eigenvectors, we start with lambda 1, which is equal to negative 5, will give us eigenvector 1, which we don't know when to find. Now we come from our A minus lambda multiplied by identity matrix, where we add 3 minus lambda, 2, 4, negative 4 minus lambda. Now starting with our lambda 1 equal to negative 5, we equate negative 5 here. So we have 3 minus 5, which is 8. Then here we have 4. Here we have 2. Here we have negative 4 minus 5, which is negative 4 plus 5, which is 1. Now to find our eigenvectors, we need to perform a row operation. Row operation means that we have 8, 2, 4, and 1. We add 0, 0 on the left, then we perform a row reduction. So let's have 1 over 4, a quarter, row 1, and the answer we put it to row 1. So a quarter times 8 is a quarter, we have a quarter, sorry. A quarter times 8 is 2. A quarter times 4 is 1, that is 0. Let's maintain row 2, 1, 2, 1, 0. Let's have row 1 minus row 2 and our answer to row 2. So row 1 minus row 2, we have 2 minus, let's maintain row 1, which is 2, 1, 0. 2 minus 2 is 0. 1 minus 1 is 0. 0 minus 0 is 0. So we realize that in our row 1, we have 2x1 plus x2, which is equal to 0, meaning our 2x1 is equal to negative x2. Therefore, our x1 is equal to x2, negative x2 divided by 2. And our x2 is x2. x2 is equal to x2. Therefore, we have x1 is negative half x2. Our x2 is x2. We realize that let's factor out 2x2 into, here we remain with negative 1. Here we have got 2. Therefore, our v1 is equal to negative 1, 2. our eigenvector 1, which is v1, is equal to negative 1, 2. Let's find our eigenvector 2. Our lambda 2 was equal to 4. Therefore, we want to find eigenvector 2, which is equal to unknown. Now, to find this, we use A minus lambda times the identity matrix, which was 3 minus lambda. Here was 2, here was 4, negative 4 minus lambda. Now, our lambda 2 is 4. We equate 4. 3 minus 4 is minus 1. There we have 4. Here we have 2. Then minus 4 minus 4, which is minus 8. Now, to find our eigenvector 2, we need to perform a row reduction. Performing reduction, we have 1, 2, 4, negative 8. We add 0, 0. Let's have a half row 2. Our answer to row 2. Therefore, negative 1, we maintain row 1, negative 1, 4, 0. Half times 2 is 1. Half times negative 8 is negative 4. Half times 0 is 0. Let's have row 1 plus row 2. Our answer to row 2. Let's maintain row 1, which is negative 1, 4, 0. Or negative 1 plus 1 is 0. 4 plus minus 4 is 0. 0 plus 0 is 0. Let's have negative 1 row 1. Our answer to row 1. Here we have negative 1 times 1. Negative 1 times 1 is 1. Then negative 4. There is 0. We maintain row 2. 0, 0, 0. So from here, we realize that x1 minus 4x2 is equal to 0, meaning x1 is equal to 4x2, and our x2 is x2. Therefore, we have our x1, which is 4x2, our x2, which is x2. Let's factor out x2. So we have x2 into 4, 1. Therefore, our eigenvector 2 is equal to 4, 1. We were told to find the eigenvalues and eigenvector. Our eigenvalue 1 is negative 5, eigenvalue 2 is 4, and our eigenvector v1 is negative 1, 2. Our eigenvector v2 is 4, 1. Now, let's see if it is, we can diagonalize A. We realize that the eigenspace of lambda 1, the eigenspace of lambda 1 is equal to basis 1, which is our basis of 1. Our basis of 1 is negative 1, 2. We realize that the dimension is equal to 1, which is the same as the multiplicity of lambda 1, which is 1. Multiplicity is 1. So it's equal to the multiplicity. Which is equal to 1. The eigenspace of lambda 2, which is equal to basis of 2, is 4, 1. The dimension is 1, and it's the same as the multiplicity, which is 1. Therefore, we can diagonalize A using the matrix. We can diagonalize A using the matrix negative 1, 2, and 4, 1. Let's give it P. We can diagonalize A using the matrix negative 1, 2, 4, 1. How do we diagonalize? We diagonalize by, we have the inverse of P. When we multiply by A times P should give us B. So let's find the inverse of P. Our P is negative 1, 2, 4, 1. Now to find inverse, we want to perform a row reduction. Therefore, we add the identity matrix to the left. Now to find the inverse, we perform a row reduction until the identity matrix in the left appears on the right. 1, 0, 0, 1 should appear in the right. Now to find this, let's have 2 R1 plus R2, our answer to R2. Two R1, 2 times negative 1 is negative 2. Let's maintain row 1, negative 1, 4, 1, 0. 2 times negative 2 is negative 2, negative 2 plus 2 is 0. Then 2 times 4 is 8, 8 plus 1 is 9. Then we have 2 times 2 is 2, 2 plus 0 is 2. Then we have 2 times 0, which is 0, 0 plus 1 is 1. Let's have 1 over 9, row 2. Our answer to row 2. Let's maintain row 1, negative 1, 4, 1, 0. Negative 1 over 9 times 0 is 0. 1 over 9 times 9 is 1. 1 over 9 times 2, it's 2 over 9. 1 over 9 times 1 is 1 over 9. Let's have negative 4 R2 plus R1, our answer to row 1. So we have negative 4 times 0, which is 0. 0 plus 1 is negative 1. Negative 4 times 1 is negative 4 plus 4 is 0. Negative 4 times 2 over 9 is negative 8 over 9. Negative 8 over 9 plus negative 8 over 9 plus 1 will give us 1 over 9. Then negative 4 times half is negative 2. Negative 4 times half is negative 2. Negative 2 plus 0 is negative 2. Then here we have 0, 1, 2 over 9, half. Sorry, this was supposed to be 1 over 9. It was supposed to be 1 over 9. There we have Negative 4 times 1 over 9 is negative 4 over 9. So here should be negative 4 over 9. Here we have 1 over 9. Now we realize that let's multiply negative 1 R1 first. Our answer to row 1. We have 1, 0, negative 1 over 9, 4 over 9. We have 0, 1, 2 over 9, 1 over 9. We realize that the identity matrix is now to the right. Therefore, our inverse is negative 1 over 9, 2 over 9, 4 over 9, and 1 over 9. Now let's have our inverse times A. It is P inverse times A times P should give us B. Now we have P inverse is negative 1 over 9, 4 over 9, 2 over 9, 1 over 9. We want to multiply this by A. Our A is 3, 2, 4, negative 4. Then we multiply by our P. Our P is negative 1, 2, 4, 1. Now we can start with these two. We have negative 1 over 9, 4 over 9, 2 over 9, 1 over 9, times 3, 2, 4, negative 4. Now we have negative 9 times 3, which is negative 1 over 3, plus 4 over 9 times 4, which is it will be 8 over 9. So negative 1 over 3 plus 8 over 9 will give us 5 over 9. Then we have negative 1 over 9 times 4 plus 4 over 9 times negative 4, which will give us negative 20 over 9. Then we have 2 over 9 times 3 plus 1 over 9 times 2, which will give us 8 over 9. Then we have 2 over 9 times 4 plus 1 over 9 times negative 4, which will give us 4 over 9. Then this one times now this times our P, which is negative 1, 4, 2, 1. Here we have 5 over 9 times negative 1 plus negative 20 over 9 times 2, which is negative 5. Here we have 5 over 9 times 4 plus negative 20 over 9 times 1, which is 0. Here we have 8 over 9 times negative 1 plus 4 over 9 times 4, which will give us 0. Then here we have 8 over 9 times 4 plus 4 over 9 times 1, which will give us 4. This is our B. Now we have diagonalized. Now this is our final answer. We should realize something, that when diagonalizing, we can simply take the eigenvalues. We find that our eigenvalue of 1 was negative 5, our eigenvalue 2 was 4. So the simplest way to diagonalize, when you are being told, we just take the diagonals of the eigenvalues, which is negative 5, 4, and add 0, 0. Thank you for watching. Subscribe, like, and comment. Thank you.